Hello, good morning everyone. Thank you for joining us to our today's session about unifying primary and secondary engineering in BIM-ready environments. My name is Jakub Grzesiak and I'm product sales engineer in Bentley responsible for electrical and plant solution. And the goal of today's session is to show our customers and the engineers around the world capabilities of 3D solution that is able to design the substation entirely. So I will start with today's plan. We will start with the short introduction, and then we will go to the technical presentation about primary design, secondary design, design verification and deliverables, and last but not least, Q&A. So after the technical session, we will have the Q&A. And if you have any questions during the sessions, feel free to write them down in the chat, in the comments in the chat, and we will do our best to answer all of the questions. So, as I said, my name is Jakub Grzesiak. I'm located in Poland and I'm in Bentley for almost 2 years. And together with me today is Sebastian Vantuch, our solution architect. So, Sebastian, please feel free to take over.
Yeah. Hello, everyone. My name is Sebastian Vantuch, and I have been working at Bentley Systems for almost 7 years right now. I currently work as a solution architect, and previously I worked as an application engineer and consultant. My focus is on the solution for the electrical utilities industry, particularly the substation design and engineering workflows. I'm based in Warsaw, Poland, and my background includes mechanical design, and as well as electrical design with a focus on a substation design. Thank you. Okay. If it comes to Open Utility Substation, first of all, we will start with the short PPT presentation to let you know what we will be presenting to you today. Our presentation will be divided into the 3 parts. The first part will be the primary design, and here we support the physical layout of the substation, including the placement of the primary equipment, like bus bars, structures, connections, circuit breakers, transformers, and so on. And engineers design the entire substation in the 3D, ensuring correct clearness, spatial coordination, and constructability from the early design stages. Second, we have the secondary design, and in this area, the solution supports the creation of the schematics and control wiring diagrams, including protection control system for your substation. And engineers can manage the logical design, wiring, and panel layouts while maintaining consistency and connectivity across the project. Finally, we will have the solution, design verification and deliverables that helps with the design validation and automated deliverables. Engineers can perform the design checks, ensure data consistency, and automatically generate the drawings, reports, and documentation required for a project deliverable. And first of all, we start with the primary design, and then I will just switch to Open Utilities substation. Okay. Okay. First of all, I would like to tell you something more about Open Utilities substation. Open Utilities substation is based on MicroStation. That means that our engine for Open Utility substation is MicroStation. It means that you have every single functionalities in Open Utility substation that you can find in the MicroStation. Also, if you work with a MicroStation, you will find familiar the whole interface, just like I said, it's based on the MicroStation, and also you don't need to have a separate license. Open Utility Substation is a standalone product for substation design. Our project is divided into the smaller portion depending on the page mode. For example, we have the 3 pages for our primary design. We also have the single line modes, schematics, panel layouts, documentation, wiring diagram, and so on and so on. I will go with the master file. The master file contains all of the 3D models that we divided into the smaller portion, just like the base or maybe different sections of your substation, and then connected using the reference for all of the for a better collaboration. And as you can see, the project is geo-reference located using the geo-reference system from the MicroStation. And we will start with the primary to build some part of our Bay 5. I would just, just zoom here, and I identify that I'm missing something here. And I can just, from the master model, I can simply click on any of my Bay 5 parts, for example, for this transformer, and exchange. And in exchange, it will automatically open the corresponding 3D models with my Bay number 5. And for it, we will be building this portion of the Bay. First of all, I will use the macro, because if we have something that is very common in our design, that we have we can call it like the assemblies. That means that every single time I have this kind of foundation, I can use the macro that will add all of the steel structures, clamps, cables, devices, and so on and so on. I'm simply going to the macro, and here I have my saved macros. One of these will be the macro L, which I can click the place macro, and using the hook point method, it will automatically add the whole assembly that I prepared previously. That is maybe the part of my library or part of my standards that I have in a company. And once I'm adding this, Open Utility Substation is ensuring that all of the elements are unique, and they are assigning the correct device tags that they are unique for the project, and also no duplication here with the name of all of the parts number. I can simply click assign, and then I insert in the macro with all of the information here. If I just create device properties here, you will see that all of the data 3D models, they are not just like the 3D geometry, but they are rich with the data. For example, like the part number, information like installation, location, unique device tag, symbol names, and so on and so on. Also, if it comes to the length of all of the bus bars, cables, and so on. Right now, I can also add more data, more information to it. For example, if I go to my properties control here, I can simply add a new properties to already existing 3D models. For example, I would go with maybe work order. I would go with my WO202502 with my BOM number document like this, and maybe revision like this. And now if I check it, I can simply have this assign. And now all of this information will be assigned to my 3D models. That means that if I go right now to any of this, like here, and I go to my symbol text, I will see some invisible data that I don't see on my 3D model, but it's there, and I can extract this to some kind of reports or data and so on. And as you can see, it's already BOM1, VOW202505. And exactly the same, I can do this during the insertion of the substation object. That means that once I have all of this checked, I can simply go to insert substation object, search by part number, and search, for example, for some clamps, or maybe by name. I just simply can go and insert the clamp by name if I don't know the part number. For whole NEMA, for example, barrel, here, place a symbol, and using the hook point method, my symbol will be automatically snapping to this little hook points. It prevents me from making any mistakes if it comes to any misalignment with my 3D models, and hook points also determines the connection points. That means that I don't need to be a master in the 3D modeling, because the hook points will ensure that I'm inserting all equipments properly if it comes to the position and corresponds to the another device. And I just kind of simply click here, add this. And now if I just go here, go to the device properties, I will see my clamp maybe I will need to add the part number. I can simply add the part number here. And now I have a part number with assigned balloon number, device type, everything. And just because I was doing this with the proprietary control, I can simply go here, symbol text, and I have associated the properties control for it. Okay, another thing that I can do is that once someone else prepared, I know, single line diagram, maybe of my substation, I can go to insert substation object, and instead of searching for the part number, I can simply go to the symbol by device ID. That means that I will be searching and inserting the symbol by that is already existing in some other representation of the substation. For example, maybe it will be like the representation on the single line diagram. I can just simply click 5 here, and I see that there is like the on single line diagram, I have my secret breaker here, but this is telling me that it's not already placed. That's why I can simply click the place symbol, place it on my foundation. I can rotate it simply as that, and then device properties, everything. And later I will also show you how to navigate between the different representation of the same symbol. Then we can also add another clamp. Maybe it's the same clamp here. Here, I can click on my clamp. And another thing to do will be connect this to device using our insert cable and bus object. To do this, I will just simply go filter by part number and try to find my cable, which will be like 4323278. Conductor here, insert. I can change the face of this. This is like the face C. Simply change face C. Method hook point, and I don't need to be very precise. I need to click somewhere near this clamp, somewhere near this clamp. Then I have my cable and bus object settings. We have the different algorithms. The first algorithm can be like the spline stack, catenary stack, age change. If it comes to rigid bus bar, we will use the spline stack. The offset means only the offset from the clamp that cable can start to bend, not will, but can start to bend. I will just simply insert this value. I can do the preview to see the shape of my cable. And now just simply click OK. And OpenUtility Substation will create the 3D model representation of the cable with the real curvature and the bending. And also, if I go to device properties, I will see also the quantity of it. And this quantity, because I'm using here the ANSI mixed standard to show you that we can use the ANSI and ISC, but this particular file is in the feet units. Okay. What about if I'm missing something here that I have my here my cable, here I may have my clamp. I can just simply go and reference the main bus maybe and see how I will connect to it. And I will just simply only do this portion of the drawing. I can simply click, activate the reference. That means that I'm activating the different file with the collaboration with my already existing. I just can go on the top, insert a substation object, and I would like to insert the clamp that will be following the bus bar. And to do this, I'm just inserting this one, 0716. And here I will not be using the hook option, but cable. And I can define which cable, and of course I can just simply change the angle of it like this, define the cable, and right now it's following the center line of my bus bar. I can simply use the standard microstation tools like setting the original point here, insert, then insert the clamp, 4323278. second. Oh, maybe I would just this one. Yes, yeah. I can just simply rotate here and deactivate my default, and here add the connection between them. Insert cable and bus. Here, insert. This is like my face. A. Here, here. Blind stack 0.1. Preview. Click OK. And now it will create the connection between my tree. Okay. If it comes to the primary design and also the 3D models, as I say, these 3D models are enriched with the data, and not only with the data, but maybe with some hyperlinks. If I'm creating like this kind of circuit breaker and I'm inserting it, I can simply go to my part number, and maybe I have some associated documents, like, I don't know, maybe, for example, some kind of plate that this gas circuit breaker with all of my ratings. Maybe I will have something more like some product line for this particular circuit breaker, and then I can check it. I don't need to manually search in my, SharePoint or any, drive in searching for the particular information about this. Maybe some kind of drawings. If I have some clamps that I would like to see this clamp dimensions or something like this, no problem at all. I can just open my sheet that is created especially for this. Okay, and now I told you about the connectivity between the primary and secondary design if it comes to the navigation. And I can achieve this by simply going here and navigate. And because this circuit breaker can be represented in the different forms, it will be represented as a 3D model, it will be represented as a single line diagram, and maybe I just want also to represent the protection control for the circuit breaker. And I can collect them together in one unified design environment for this intelligent substation design. I will, for example, at the very beginning, I showed you how I can use the device ID if it comes to my circuit breaker, but I can do exactly the same if it comes to the 3D models. That means that if I first inserted the 3D model, just like with the transformer, I can simply go with device by ID here and search for this here. And I have my 5 tier 1, place the symbol. I can place it right here. It will be associated with my transformer. Click OK. Boom, revision, everything. Maybe I just want to add some informations, just like to hand this and maybe this information. This information I can add manually, or it can be the part of your part database setup. Okay, as you can see, this information are here. If it comes to the macro, I can also use the macro in my single line diagram, schematics, and so on and so on. I can just simply go to the insert macro. And from my custom 2D, I can simply add the whole bay as my single line diagram. And right now I can change the information like the device stack, or just save and exit, and Open Utility Substation will ensure the next available device stack, not duplicating anything in your design. If I can save and exit. Okay. If it comes to any duplication, just like I said, I can just simply do exactly the same. I can go here, device properties, and maybe I would like to do exactly the same with my if it comes to insert symbol, I can insert symbol, this one, place symbol, be sure that I'm having exactly the same information like here, and to not duplicate anything. Right now, I will not be duplicating anything. And right now, if I check here, I have site 230 here and 5. If I change it here, site and 5 here 1, then it will prevent me from making this kind of duplication, because each of the device should be unique for the particular location, installation, and device tag. I will say no. Click OK. No. OK. If it comes to any changes that I can do here, if I go here, for example, and change my device properties, like, I don't know, maybe truffle, something like this, I click OK. And if I move back my 3D representation of the same transformer, it will also be changed. I don't need to manually change anything if it comes to the naming, the installation, and also the part numbers. Everything is connected together. If it comes to the primary design, I will also show you, because I showed you already, we have the single substation object. That means that any circuit breaker, transformer, disconnectors, and so on and so on. But we also, we have the linear object like the cables. And the third part that we can use is like the repeating. The one of the examples will be trenches. That means that I have my trench system here, and I missed it, and I didn't add the last portion of it. And I can just simply go to Insert Substation Object, go to Repeating Parts Type, and go with my 3D strain. Just place the symbol, click somewhere here using the hook points here. And as you can see, it's having the gap here. It's having the gap here. And Open Utility Substation, because it's repeating symbol, that means that it has like one piece, second piece, third piece, and so on and so on. Ask me if I would like to extend my trench or maybe cut it to the exact length. And I can just click cut, and it will cut it to the exact length, as you can see. Okay. Now, if it comes to the primary design, this portion, we will move to the secondary design. And in the substation secondary design, we will focus on the schematic, on the wiring diagrams, and protection and control system for the substation. From here. Now I will open one of my schematic pages. It will be like the fourth. It's like some generic schematic page for my first circuit breaker. Here, as you can see, I can navigate between the different representation of it. That means that I can just simply click single line mode. It will automatically follow to the single line mode of the circuit breaker, or maybe I can just follow to the 3D layout mode of this circuit breaker to the bay 1. It's not a bay 5. That's why we have all of the cables here, and we don't have any cables here. If I go back to my schematics, I can change anything here. And also, if I delete this, Open Utility Substation will automatically mend the wires, because in Open Utility Substation, this is not a simple line. It's a wire. That means that it knows exactly what kind of connection point is connecting to, and also it behaves like a wire. That means that if we are deleting some symbols, it automatically mend, or if we add some symbols, it will automatically break and give an information to the Open Utility Substation about the connectivity. I will go to another page for the schematic page, the 7th. And this is more like some relay page. And to better understand something that I will be doing here, I'll go back to my presentation, and I will tell you something about the cross-referencing about the family. Okay, When we work on the secondary design, one of the biggest challenges is keep track of how all the wires, terminals, and device signals related to each other across many drawings. A single device, like a cell relay, can appear in the multiple schematic pages. Its input on one page, maybe its output on another page, its power supply on a third, and maybe physical terminal layout somewhere else. And without a system to link these pieces together, it becomes very easy to make a mistake. And that is where the family and cross-reference come in. A family is simply a group of the symbols in the project that all belongs to the same physical design. For example, if you have the cross-referencing family with my relay, all of these inputs, output, connection points can be a separate symbol on the totally different drawings, but software need to recognize that each of the symbol belongs to the one particular device, to not duplicate any bill of material list and so on and so on. And to also, if I would like to modify the name of the device, it will modify all across the whole drawings associated with this particular component. And we have here we have the digital outputs for our communication ports. And in the schematics, each of these terminal might be represented by separate symbol, just like I say. And cross-reference is the next step, because once the software knows which symbols belong to the same device, it automatically display reference that link them together across the project. And if a designer is looking at the relay's input terminal on one page, they can immediately say where the related output or parser or internal logic is shown on another page. It's like creating a map that connects all views of the device, so engineers always know where to find the matching information. Okay, and then I will go back to Open Utilities Substation, and I will insert the symbol by device ID. If I go to insert symbol by device ID and go symbol by here by device ID, I can search for my 90. And I have two different 90, one of this page, but I will be looking for the location line arrow 1. Because the uniqueness of the name is installation location tag. That means different location, and we can have this exactly the same tag. And here, as I can see for my L90, I have different symbols that they are representing the different function of this device. And for example, pretty much every single symbol is already placed because I have an information here. Now I can simply click on one that is not placed, my child one for this particular, which will be our schematic for the G current and voltage output, and place the symbol somewhere here, aligning with this. It will automatically assign the device, the family, the connection point text, everything, and also associated with the IO text definition. Click OK. And now from here, I can simply navigate to the maybe panel layout mode to see where exactly this particular relay is. And this view of the panel, it's up to you. I created very simplified one, but it's not a problem at all to have this very detailed way. And from here, I can maybe go back to my here. I can go back to my, sorry, not here, here. I can go back to my schematic and maybe go to one of this, like here, page number 7, another representation. Yeah. If it comes to the information that we can also add here, maybe we have someone who is like responsible for creating the information about the particular outputs and the inputs for the instruction for our substation. Then I can simply, you can see this question marks. I can simply go to my file, go to the options, and here I have the PLC settings. In the PLC settings, I can import the PLC or relay file that will automatically add all of the text to my inputs and outputs. And simply by this, I can just replace text in a project, wait a while, and it is like the XLS file that I can have from my colleague that is, preparing this for the logical function of substation, and then go back here, and I will see all of the information added here directly from the Excel spreadsheet list. Okay, then we will go to the file, open the wiring diagram mode. If it comes to the wiring diagram mode, we can simply place the symbols in the wiring diagram mode, and they will be automatically updated with the information such as connection points, references, cross references, bridges, and so on, just like you say here, some bridges, cable description. This is particular for the terminal block, terminal strip, and maybe for some other switches or test switches or so on. And it's live. That means that everything that I have here is not manually done. That means that if I go here, just remember that we have this here, I can simply navigate between the schematic mode, maybe go to my first terminal. And first of all, I will draw a wire to add the wire between my terminals, making this kind of bridge or jumper. And then simply I can just go here and maybe swap in terminal pin and plug manager. I will swap the position of the different input and output of my terminal pin manager. Right now it's verifying everything. I have my T1, and I see also where I have my jumper right now. And I can simply go with the swap target, apply, click OK, go back once again to my wiring diagram mode. And in the wiring diagram mode, I still see the old version of it, because it's up to you if I would like to update this. That means that I need to go to the output, and here I will have the update wiring diagram. And once I will be sure that I want to update this right now, because I made every single changes, and now I want to update this, I'm clicking OK, and it will update my wiring diagram, changing the symbol with the intelligent information from the Open Utilities substation project information, as you can see here, and also added this kind of jumper here or bridge if it comes to the update wiring diagram. Okay. Okay. If it comes to right now, we will go back to my PPT slide. And now we will talk something about the design verification and deliverables. This is like the final steps of our project, probably. And we will be talking about the lightning protection, about the clash detection, and also about the deliverables and the creation of the 2D drawing out of the 3D model. I'll go back here. And if it comes to the design verification, we will start with the lightning protection. I will open my lightning protection model in which I add my mast. And if it comes to lightning protection, Open Utility substations support both mast and strung wires using rolling spree method to create the visual site coverage for you to better understand if your substation is protected. As you can see, I have the mast that I added here, just in the random location. And simply, I can just go to the lightning protection, show which mast I added. And this mast can be added as the 3D models. It can be also the point. If I don't have a 3D model, I can just simply specify the point, the top of the mast using the points. It can be also point from the reality mesh or some point cloud if we are talking about the brownfield substation. And then I can use the rolling spree method and the different radius for it, we have to 20, 40, 45, 60 on other, if we want to include our own ground height, if you are operating on a different ground height than 0, 0. And then I can simply click process. And now it will create the 3D coverage, showing me exactly what is covered by my my lightning protection. If I change, for example, to 60 and click process, once again, it will change the radius of the rolling spree I can group the different mass, then create the 2D section of it, all of the reports and any calculation to show if we have any particular calculation if it comes to the lightning protection. I created something here, that's why it's like yeah, loading. Okay. If it comes also to the reports for the lightning protection can be customized if it comes to the protection report template, and also if it comes to the, I can send it to the drawing to create the drawing sheet, or send it to the file. Yeah. Okay, and if it comes to open it into substation, yeah, I have this height and so on. Okay. I will go file to also show you the design verification using the clash detection method. And here I will go to my master model, because in the master model I have every single design in one place. Okay, can simply rotate it. If I don't want, I can also, you know, just not use the Google Maps for my design if I don't need to. And from here, I would just simply search for the clash detection. And in the clash detection, I will show you the two different clashes. The first will be like the hard clash, which will be like hard clash between the control house and maybe my trench system. The hard clash, that means that it will be searching for any clearance that is like lower than 0. That means that there is like hard clash. And if it comes to the clash tool, we can simply clash between the different levels of the same design, between the different references, even with even including the point clouds, and name groups. That means that I can group like all of the trenches, or maybe group all substation, and so on and so on. And simply by this, I can just, here I will be self-checking the control house and trenches. And if I click, it will immediately also show me the clash. And now I can see that there is like the clash between my trench and my control house. And I need to resolve it. I need to go back and delete maybe the some portion of the trench. I can simply clear all. Yes, clear. And go to the soft clash using the high bus to ground. And here I also change my measurement units to be centimeters to show you if it comes to the soft clash between the high bus, that's mean this one, and my ground, that's mean my digital terrain model. And if I set up my soft clearance to be as 1000 centimeters, I can proceed. I don't see any clashes. But what about if I go back and it needs to be like this? Then it will immediately show me that we have a clashes between the 3 different bus bars. This bus bar, this bus bar, and this bus bar. And this kind of, you know, clash detection can be rule based. That means that I can apply the multiple rules or criteria to it and create as many clash as I would like to see for the different project requirements. And the results, of course, can be exported to the Excel or the GPS system. Yeah. And if I click close, yeah, I would like to, yeah. And then we will go to my documentation, because the one of the last step will be to create the 2D outputs out of the 3D model. And just like you see, I added some information like maybe some dimensions and also intelligent balance, and everything that you can see here is created from the 3D model using the reference option, and then you are referencing the 3D model from the different view, like the isometric, top view, left view, and so on. And to add any annotation is very simple. You're just going to, for example, section cut, insert balloon, and right now this balloon here tool, I can simply click on my transformer, and it will give me the associated balloon. I can click where I want to place it here. Maybe it will be for my bus bar, part number, and I can associate this here, no problem at all. At the end, I can also, make any slightly changes to it. And also is interactive. That means that I don't need to every single time, recreate this once again. If there is any changes, I can just simply delete this balloon, go to my bay 1, and in my bay 1, right now it's like update, and in my bay 1, I can just simply, for example, delete, go back to my documentation, and right now it's refreshing and showing me everything that I did. That's mean that I deleted the circuit breaker. That's mean that another thing that is disadvantageous if it comes to the using open utility substation in your intelligent substation design is that you don't need to recreate the drawings even if you change something. That means that you can have the different views. As you can see, I have this view, and normally in the 2D drawing environment, you will need to, all of the views you will need also to delete. In the 3D design environment, we just, once we change something, it will be reflected in all of the drawings that are associated, as you can see, even in isometric drawings. Okay, right now we will talk something about the reports. If it comes to open utilities substation, we have the run reports option that will give you an access to predefined reports such as bill of materials, cable list, job costing, wire list, and so on and so on. And of course, all of the reports, they are highly customizable and configurable for your needs and requirements. And also you can create your own reports. Open Utility Substation is based on the SQL server. That means that every single information that you are adding to your project is also added to the SQL server as an intelligent information. And then you can use the report tool to access this information and create this kind of report, intelligent report. If I, for example, go to my bill of material quantified, I can simply go to one of it, A4. I have the different filter options, different sorting options. I can output this to the XLS files, PDF, TXT, and so on, print, or just I will simply click preview. And right now, as you can see, it's automatically creating me bill of material list. And you can add your own information like the logo, maybe different colors, different columns, informations, and so on and so on. And I associated some of the devices with the different work order. If I go to my bill of material for a substation, one of the reports is the quantity for the VOPOM. And in the filters here, I can specify for which work order I would like to see my bill of material list on, or maybe I can also change to have the only bill of material list for my clamps, maybe cables, or maybe only foundations. And right now I have this for my W001. Click OK, preview. Right now it's only getting me information about this 01. If I change the filter, go back, change the filter to this one, click OK, preview. Right now, it will give me totally different bill of material list corresponding only to my work order 02. Okay. Also, if it comes to this secondary design, the report that can be very useful, especially if we are talking about the projection control, will be the wire list. And here, the wire list A4, I can simply go with preview. I want to recompile the connection list. And right now, OpenUtility Substation will give me the list of all of the wires that are used in the protection control schematics with the wire number and also target from and target to. Some of the wires are exactly the same because I'm using, in this particular project, I'm using the potential wire numbering instead of the unique wire numbering, but you can change this in your project settings, no problem at all. And as you can see, you have the target, from which connection points if existing, and all of this in the blink of an eye to create this kind of wire list for you. That means that no more manual work, no more manually targeting which of the wire is connecting with which, and so on and so on. And this, all of it, because of the BOM manager, in which you can just you can add the different work orders if you are talking about the substation that maybe you also need to maintain, and create another work order for, I don't know, expanding the substation, maybe changing something, and you would like to only include the parts that you added in the recent work order. Okay. Yeah. If it comes to OpenUtilities substation, we talk about the primary design and how it supports the physical layout of the substation. Secondly, we talk about the secondary design, about the schematic and control wiring diagrams, including protection control system. And at the end, the design verification and deliverables such as lightning protection, clash detection, and creating the reports and drawing for your output such as deliverables. And that's it from my side.
Yes, thank you very much, Sebastian. A really amazing presentation. Now, according to our agenda, we will move to the Q&A session. But before I, let's say, read some questions from the chat, I would like to ask you about several things as we were discussing, let's say, BIM-ready environment for substation design. Maybe you can tell us also a bit more about the capabilities of file exchange and working with the common data environment, as the base of the, let's say, BIM workflows is exchanging the IFC files, for example. So maybe you can tell a little bit more about this.
If it comes to OpenUtility Substation, OpenUtility Substation support the common data exchange format, such as step files, DWG, DGN, but also in the 2025 version, we also have a support for the IFC export and import. That means that the collaboration between the different infrastructure software is easy, and there is no problem at all to include the BIM coordinated model to it. And if it comes to connected data environment, yeah, am I right? You asked about the connected data environment also, yeah?
Yes, definitely. It's very important as a BIM workflow.
Yeah, if it comes to connected data environment, OpenUtility Substation is fully integrated with our ProjectWise solution. That means that OpenUtility Substation can work with the managed workspace and workset with the predefined workflows of the document flow, and also all of the information about the revision, checked documents, checking in, and also to be sure that every single engineer work with the latest information about the project.
Yes, that's definitely crucial. Also, recently I received a lot of questions like that. Let's say, how flexible is Substation when it comes to adapting to different project standards?
Yeah, if it comes to the standards, Open Utility Substation is designed to be highly configurable, which allows the companies to adapt the software to their internal engineering standards. User can define the custom libraries, templates, symbols, and design rules. This means that the same software can support different utility standards, naming convention, and documentation requirements across the project of the regions.
And as you mentioned models, you mentioned standards, let's say, but maybe it's also very important if, let's say, company starts with Open Utility Substation, does it include, let's say, libraries of ready components, and if it's possible, and how easy it is to create a custom components?
It's very, very good question. Open Utility Substation provides equipment library that include the commonly used substation components such as breakers, disconnector, and other primary equipments. In addition, every user has an access to Component Center available on a Bentley Collect Center, where you can find the libraries provided by the different manufacturers, such as ABB, Siemens, and the S libraries includes manufacturer-specified components that can be used directly in the design. If a specific component is not available, is missing, user can also create their own custom 3D models and add them to their project library. And once created, these models can be reused across the different projects, helping teams build their own standardized equipment libraries. You can do this using the standard 3D models tools that you find in Open Utility Substation, exactly the same that you have in your MicroStation, or maybe ask your manufacturer if they already have any step files, and then we can just import it and add the intelligent information, creating the intelligent substation design environment for your company.
So let's say if we have the step file from the manufacturer, they are actually pretty commonly shared. So we can, if I understand correctly, we can add hook points to the right, let's say, places.
Yeah, hook points, intelligent information.
Then it will
like
be
this kind of part database. Yeah, if it comes to intelligent information, I mean by any metadata such as a voltage level, like maybe some kind of different, just like I added the work order, BOM list, and so on and so on.
And okay, so maybe thank you very much for the answers. And I can see we actually have some questions in the chat. So let me start with the first one. Can we get a table with the list of the clashes if we are doing the software hard clash detection?
You mean that the export as a table, yeah?
Yes, can we simply get a table of clashes? If there are some clashes during the clash resolution, are we able to get a table of these clashes?
Yes. As an export, you can export this as a, just like I said, as an Excel spreadsheet, creating the.
Okay, so that answers the question. Like I will follow with the following one. Can we run a clash detection with a reference coming from other softwares, different file extensions like IFC or DWG?
Yes, we can do this as well. It can be like the different extension. It can be also like just like I mentioned, point clouds. That's mean if you have any brownfield substation and you would like to also see if you have any clashes with the point cloud, you can also achieve it.
Okay, so it's really working for brownfield projects as well. That's really amazing. And another question we have in the chat: what is the? Oh, this is the, let's say, heavy one. What is the biggest advantage of using model-based approach to the substation design compared to the traditional? So let's call it 2D methods. Maybe you can tell us a little bit more about this.
Yeah, first of all is the better visibility of the whole substation model, as you know, there can be like the thousands of the different clamps, cables, and so on. In the 2D, it's a lot tougher to see any changes or any clashes there rather than in the 3D. Another thing is, and especially if we are talking about the GIS substation, when you have the gas insulated substation inside some kind of buildings, and then you need to coordinate between the different design departments. For example, you need to coordinate with your mechanical design or building design, also HVAC, plumbings, and so on and so on. It's a lot better to coordinate everything in a 3D. Then, if there is any changes to your design, in 2D environment, you will need to change in every single drawings from the different perspective. Like, for example, you have the top view of some kind of circuit breaker. You also have the front view maybe, and so on, or maybe a different cross section. If you change something, you will need to change in every single drawing. In a 3D model, because the 2D drawings are automatically generated from the 3D model, it will automatically update all of the views related to the changes that you made. Another thing, if it comes to the 3D, is like possibility of the different verification, just like I mentioned with the clash detection, with the lightning protection. And of course, the whole world is moving forward. That means that the requirements, if it comes to the 3D modeling, will be more and more often if it comes to the standards requested by the owners and operation of the grids in the particular countries.
Yes, thank you. Maybe I'll add something to this question also from my side, because yes, one thing is the requirements, let's say from our contractors, from EPCs, but another thing is simply reliability of the design itself. So what we can achieve with using 3D design is simply reduce errors, that our design is faster, and we can rely on it better. It's also much better for the cooperation, for the error detection. So simply the 3D environment is giving us tons of standard advantages over the 2D environments. It's much better visible. Okay, and last question I can see here on the chat is what is planned in the future to be developed for substations?
For the substation? You mean?
I understand it as for open utility substation, but.
Okay, do you want to answer or should I answer it?
Maybe you can answer, yes, please.
Okay. If it comes to the open utility substation, every single year we are updating open utilities substation with adding new features and tools to our tool. If it comes to the Bentley approach to the Plus product, we also have in the development our next generation software, which will be like the Substation Plus, which will be the AI-driven, tool, which is in the phase of the development and early adopters process. And yeah, this is like the future of the next generation softwares.
Yeah, so yes, we got clarification from Niels that it will be, let's say, he's referring to new features of Substation. So we can say that there is completely new tool coming. Let's say it's Substation Plus, and it will be, let's say, it will be having a lot of new features, but it was, let's say, presented, but we cannot say more yet. So expect, let's say, news from us in the future, in the near future. I think we can close the Q&A session now. And
one thing maybe that I can
one
thing that I can add, that because even if we have the Substation Plus developments, plan and so on, open substation still will be like one of the products, and open utility substation will have a smooth transition if someone wants to transition to the Substation Plus one. Substation Plus will be available for all of our users. It will be up to the user if they like to use open utility substation or a Substation Plus. But okay, the so transition between the two.
You answered the next question here, but yes, regarding, let's say, our contact data, also, we would like to stay in touch with you. Our goal, let's say, is we are able to set a meeting with you and analyze your specific workflows, your specific situation, and we can meet and we can look for improvements together. We can analyze your workflows, and we are happy to do that. So you can either use our contact data on the screen, or I also prepared a QR code you can scan, and it will directly ask you on your mobile phone to send us an email. Everything is ready there, so you can just send us an email using this QR code, and we will. It's like a meeting request, so we will of course contact you after the webinar. So that's it from our side. Thank you so much. Thank you, Sebastian, for amazing technical presentation, and thank you all to all our viewers for staying with us. I hope to see you soon in the future, and thank you again. Have a good day. Goodbye.
Thank you.